Good evening. Welcome to Moyne College. Tonight is a special night. Tonight we have the inaugural lecture in a major initiative we are starting here at Moyne. It will be a 2-year lecture series devoted to a focus on science and religion in modern America. This series was developed by Father George Coyne, our first McDevitt Chair, the McDevitt Chair of Religious Philosophy, working closely in partnership with Dr. Affeldt, who is the director of the McDevitt Center for Creativity and Innovation. These two men have both joined us within the past year or so, Dr. Affeldt prior to Father Coyne, making a substantial difference here on our campus. Tonight's topic specifically is evolution, creation, and intelligent design. All of this is made possible by the McDevitt gift. Many of you may know that the McDevitts were close friends of the college. Mr. McDevitt had served as a regent and a trustee. Mr. McDevitt was the largest single shareholder of IBM stock in the world, passed away in the fall of 2008, and left Moyne a gift, which at that time was valued at $50 million. That gift is the largest gift given to any nonprofit in the Syracuse region and outside of Cornell University in all of central New York. That gift today is worth over $70 million. It has allowed us to do phenomenal things in terms of some of the people we've been able to attract to the college, some of the facilities we've been able to transform, and the programming we've been able to do, including the series you're here for tonight. One of the most amazing things about Mr. McDevitt is that he was not a Moyne alum. He was a 1940s Georgetown alum, but he fell in love with this college. He had a cousin who was a Jesuit, who was a physicist, who was on the founding faculty of Moyne, and he got to know this college. And he loved what we do here. He's very taken with the Jesuits, but he thought we could deliver a Jesuit education in a powerful way because of our intimate size. And so he gave of his time during his life to this college, and he gave of his treasure upon his passing. This is an important initiative for us. Much of the world sees science and religion in strict opposition. As scientific knowledge accumulates, religion has a diminishing place in the world, some would have us believe. Too often that relationship is antagonistic. But here at Moyne, we believe in the unity of knowledge, the complementarity of faith and reason. Father Coyne gave the inaugural lecture in February when we opened the science building. And in there he talked about his strong belief in science and the power of science, and he is a very accomplished, world-class Jesuit scientist, but he's also a man of faith. Moyne is a place where we want to have these discussions, where we want to ask and explore the big questions, where we appreciate members of the greater Syracuse community coming here and joining us, faculty, students, and staff of Moyne, to think about the questions that we pondered, to think about the important questions, to consider the evidence and information, to talk about the relationship between faith and reason. We welcome all into this conversation. So I want to thank Dr. Affeldt for all you've brought us over the past year as the director of the McDevitt Center for Creativity and Innovation. Stephen, you've done some wonderful things, and we're looking forward to more. I also want to thank Father Coyne for choosing Moyne. Father Coyne spent much of his career as the director of the Vatican Observatory and then the Vatican Observatory Foundation, and decided while he was still a relatively young man he wanted to return to the academy. And he had many options and opportunities, but he too, like Mr. McDevitt and so many others, chose Moyne. He's made a great difference here. He's a wonderful gentleman. He's a great scholar. And he's a magnificent teacher who cares passionately about the development of our students. And I now have the pleasure of introducing Father Coyne, or welcoming Father Coyne, who will introduce our feature speaker of the evening, Father Coyne.
Running away. I just had a real heavy book that I couldn't carry around, so I left it on the piano. Thank you very much, Dr. Costello, for those nice words. It is really a pleasure to introduce Francisco Ayala. I won't use the words professor, professore, because we've been friends for many years, and Francisco is a very close friend. I introduce him with a great deal of pride that he is a friend, but I introduce him because of his really professional, personal, intimate involvement in religion and science in modern America. And I'd like to emphasize, as I introduce him very briefly, the modern America part. You have had the opportunity to see the leaflets, to search the web page, so I'm not going to go through all the very interesting biography. However, a few things this evening would be interesting to cite. That in 2001, he received the President's Medal of Science, the highest award given to an American scientist. He received the Templeton Prize. And I like to cite what the Templeton Prize is because, Francisco, it says a lot about your career. The prize is given for exceptional contribution to affirming life's spiritual dimension. He received 20 and maybe more coming on honorary degrees from universities in 9 countries. That's a recognition of his professional life. He's written numerous books and articles, professional and more popular. Among them, I've always been interested in the title of one, Am I a Monkey? I've brought this book because it's a heavy, big book, okay? It's 510 pages. It's the proceedings of a conference we had at the Vatican Observatory in 1998. And Francisco wrote a very important introduction to this book, The Evolution of Life, an Overview. It was published in the book following the message of John Paul II to the Pontifical Academy of Sciences on this very topic. So you had to take second string in that case, you know. But the other point, he did a very scholarly contribution to this book. And so I can only recommend it as his scholarly contribution to the world. However, the most important thing I can say about Professor Ayala is his contribution to American society, modern America. And that is this little book that has 70 pages as compared to 550, which was commissioned by the National Academy of Sciences, the most prestigious scholarly scientific academy in America, and he chaired a very difficult job of, for modern America, how do we deal with evolution? And so the title is Science, Evolution, and Creationism. And I don't want to sort of steal, and I won't steal, Francisco, your talk, but what is this book all about? Let me say just a few words because it says a lot about Francisco, who will talk to us this evening. Evolutionary biology has been and continues to be a cornerstone of modern science. This booklet documents some of the major contributions that an understanding of evolution has made to human well-being, including the contributions to preventing and treating human disease, developing new agricultural products, and creating industrial innovation. We are not listening to an ivory tower scientist. This publication, written to serve as a resource for people who find themselves embroiled in debates about evolution, it provides information about the role that evolution plays in modern biology and the reasons why only scientifically based explanations should be included in public school science courses. Some have argued that science teachers should teach the controversies surrounding evolution, but there is no controversy in the scientific community about whether evolution has occurred. At the end of the booklet, there are a few, it's like, hands-on chemistry or hands-on biology. The end of the booklet, there's some very nice questions to focus anyone's attention on what are the issues. I've selected two of the questions. Aren't evolution and religion opposing ideas? Isn't belief in evolution also a matter of faith? Francisco, we are very grateful for you, I personally, that you have, from the many obligations you have, come to us to make an important contribution to this community that serves not only scholarship, but it serves the problems that we face in modern America. Francisco, thank you. Please.
Thank you, Father Coyne. President Pestello, Father Coyne, university authorities, faculty, students, and other distinguished guests. It's a great pleasure for me to be here. I have never been at the Moyne College, although I lived in New York City for 10 years, and I had been in Syracuse a number of times. But I was very excited about coming here when Father Coyne invited me. As he has pointed out, we have been friends for several decades, from times before many of the students here were born, and we have collaborated in various ways for various good purposes, we hope. So thank you for inviting me, Father Coyne, and thank you, President Pestello, for having me, and thank you all for being here today. On April 28, 1937, still early in the Spanish Civil War, German airplanes, Nazi airplanes under the command of General Franco, bombed the city of Guernica, a small city in northern Spain in the Basque Country. The Basques were opposing the coup d'etat that had been initiated by Franco, and there was a massive bombing of the city, small city. There was no military target of any kind. 7,500 people, 25% died as a consequence of the bombing, 1,750 approximately. The great Spanish painter Picasso had been assigned by the Republican government in Madrid to paint a mural for the Spanish pavilion in the world exhibit that was going to take place in October in Paris of the year. Picasso, hearing of this massacre, in a fit of manic energy, he outlined, sketched completely this painting, which is a huge painting, it's 23 by more than 8 feet tall. He sketched the painting and then painted it, and it is clear that Picasso painted this painting for a purpose, to convey a message. The horrors of war, the inhumanity of humans to humans, and that's the reason why the painting exists. Is the same, the reason why a watch exists is because it helps us to tell time, and that's why it has been designed in a certain way, and a car has been designed for transportation. These are the letters of the alphabet, as you can see, A to Z, and the digits. These are butterfly wings. Clearly, we could use these letters to write text in English and the digits to make arithmetic calculations, but I think we would all agree that that's not why they were designed the way they are designed. The same way we can use mountains for skiing and the oceans and the rivers for navigation, but they have not been designed for that purpose. What about the human eye? My message today is the human eye has something in common with the painting and the watch and the car, and something in common with the butterfly wings and the mountains and the oceans. What it has in common with the painting is that if it were not for the purpose it serves, and the same with the watch or the car, it would never have come to exist. The eye has been designed for the purpose of seeing, and that's why the eyes exist. What it has in common with the butterfly wings and with the mountains in the rivers is that it has come about by natural processes, not by explicit intentional design. So that will be my main message today. Combined with that message is my view of the history of science in the modern world, in the only world in which science exists. The narrative that one finds in books on the history of science is that there were two major revolutions which account for science in the modern sense. The Copernican revolution, which started with Nicolaus Copernicus, who in his last year of life, in 1543, published this book on the revolutions of the celestial bodies. And the Copernican revolution, according to this narrative, says that what Copernicus did, and the revolution that ensued, was to remove the Earth from being the center of the universe as it was at the time conceived. There it is in a German textbook of the time, with probably cannot read this in Latin, by the way, the scientific books, and the followers also, Galileo and Newton, so they were all written in Latin. So you have the Earth in the middle, Terra, and then you have here Mercury, Venus, then the Sun, then Mars, Jupiter, Saturn, and then the constellations of the stars. That was the view of the universe at the time, and this is a drawing from Copernicus' book. The Sun in the middle, then Mercury, Venus, the Earth with the Moon, Mars, Jupiter, Saturn, and the stars. So the Copernican revolution took the Earth from being the center of the universe to be just one more planet. And as you know, now we know one more planet around an average star in an average galaxy among the 100 billion galaxies or so that exist, each one with 100 billion stars. The second revolution, according to this narrative, was Darwin's revolution. And what Darwin accomplished was, in this book, The Origin of a Species, published in 1859, to move humans from being the center of all life into being just one more species, related by descent to all others. And this is represented this way. This is a modern drawing. Here you have humans and chimps. They are our closest relatives, and we have a common ancestor, and you have the two lineages going one to us, one to the chimps. Then we have a common ancestor farther back with the gorillas, and so on. So humans were no longer the single central species in the world of life. Well, this narrative of the history of science, of the history of ideas, is very unsatisfactory, because it does not tell what is most important about these two revolutions. And it is that jointly represent the beginning of science in the modern sense, the scientific revolution as such, as one process. to understand the Copernican revolution properly, one has to see it in terms of his followers, of which I have identified two here, living 1 century apart of each other and apart from Copernicus, Galileo, and Newton. And what this revolution was the approach to the universe as a system of matter in motion that could be explained by natural laws. Laws that were universal and would apply on Earth as well as on heavens, and that could be subject to observation and experiment to confirm or reject them, and laws that could be formulated in very simple ways. Like here you have Galileo, Newton, like the force equal mass times acceleration, or the inverse square distance relation of attraction among bodies. The attraction between two bodies is directly proportional to the masses of the two bodies and inversely related to the square of their distance. Well, they had left out organisms, and they have left out organisms for a tradition which was still prevailing in the Judeo-Christian tradition and in the monotheistic religions, that organisms are different. Organisms give evidence from the sign, and therefore they have to, where there is the sign, there has to be a designer. The argument from the sign, as it is sometimes called, was expressed better than by anybody else before or afterwards by William Paley. William Paley was an Anglican priest, public speaker, very well recognized in his time, not only because he had written about natural theology and about moral theology, and particularly he was known for his public speaking against slavery as an abolitionist. In 1800, he became somewhat ill. He had to give up his speaking career and decided to study biology. Biology had advanced enormously through the 18th century, and he, in this book, Natural Theology, published in 1802, he summarizes the best biology of his time, and very well, very accurately. But the book is just an extended argument of the notion that wherever there is design, there is a designer. And of course, it's an argument for the existence of God and God as the creator and the designer of all the living organisms. He starts the book by saying, imagine that I am walking on a prairie and with a friend, and suddenly I kick a stone accidentally, and my friend asks me, where does the stone come from? And Paley writes, I could tell my friend that for all what I know, it may have been there forever. I have nothing to explain. But assume now that a little bit later, we accidentally find a watch on the ground. And he asked me the same question. Obviously, I cannot give the same answer. The watch consists of many parts, very well integrated, so that it will only function, it all have been put in the precise way. So there's a watch, there's a watchmaker. And then he starts to develop the argument from the sign for all of life, and it's very extensive. It applies to all sorts of organisms, plants and animals, all sorts of organs, relationships between organisms, predators and prey, the sexes and everything else. But one of his early arguments, his first argument, is about the human eye, and he points out that the human eye, has a number of parts shown here, that unless they are put together the right way, it's not going to function. So it cannot come accidentally to be, it has to be the product of the sign. It was Darwin's genius that he discovered that the sign in living organisms could be explained as the result of natural processes. That the design of organisms could be explained by the same kind of laws that Copernicus and Galileo and Newton were bringing into being, in particularly the law of natural selection, which nowadays is formulated in very elaborate ways mathematically. It's a very extensive theory and the like, as well as a number of subsidiary theories. But he explains the theory at length in this book, The Origin of Species, published in 1859. And let me, before I show you that, tell you something that I was telling some students this morning. By the way, I have two very enjoyable meetings with two classes this morning, classes of ecology, and then I met also with some students and faculty at lunch, and I enjoyed those three meetings very much. But one question I was asking in one of these meetings to the students, you know that Darwin's book, The Origin of Species, is about evolution. That everybody knows that, but it is not true. It's a book about natural selection. And in fact, the title is On the Origin of Species by Means of Natural Selection. And as Darwin explains, and explained also in his correspondence and otherwise, he considered a summary of a book. It's close to 400 pages long, but he considered a summary of a book that he was planning to write in multiple volumes on natural selection. In fact, he had written many parts of it. Eventually, he never published this multi-volume book. He published different parts separately, as separate books. But it's why he didn't want to call this book Natural Selection. It's The Origin of a Species by Means of Natural Selection. But the book is about natural selection from chapter 1 through chapter 7. And then in chapter 8, he says, if natural selection is the way we can explain the design and diversity of organisms, then evolution must have occurred, and must have occurred in certain ways, which are quite different, he says, of the ways in which evolution was explained at the time. Evolution in the middle of the 19th century was generally accepted by many biologists, but they saw evolution as a process that was gradually sort of progress in organism change, changes in all relevant respects, and becomes another organism. Darwin says, no, if natural selection is the way organisms evolve, then some parts of an organism may change in one way, others may change in another way, others may not change. In different places, the same species may change in different manners. Some organisms may never change, and he points out, in fact, several organisms, one of which I will refer to briefly at the end, that for millions of years had not changed at all. So it was a completely different view of evolution, but he used this view of evolution and his evidence for this view of evolution to justify natural selection, to justify the explanation of the sign by means of this law of natural selection. And then uses 5 chapters with this evidence, and then in the last chapter, chapter 14, goes back to natural selection. Well, here is a place at the beginning of chapter 4 where he summarizes the idea of natural selection. He points out first that as the experience of farmers and animal breeders goes, variations, hereditary variations happen in plants or animals, and the breeders use those to create better varieties of corn or wheat or cows that yield more milk or whatever. So hereditary variations occur which are beneficial to humans. He says it stands to reason that variations useful to the organisms must have also occurred, to the organisms themselves. And if such do occur, can we doubt that individuals having any advantage, however slight over others, would have the best chance of surviving and of procreating their kind? In common language, the notion of natural selection is very simple. You have 2 organisms of the same species, say 2 males or 2 females or whatever, and one of them has one of these hereditary variations which allows that organism to survive and reproduce better. That variation is going to multiply, it's going to leave more descendants, so it's going to increase in frequency through the generations. A very simple notion, as I said, it's a very elaborate theory around it, and of course he adds, we may feel sure that any variation in the least degree injurious would be rigidly destroyed. Since you are looking all very seriously, I want you to relax a little bit, so I will make an observation about Darwin's writing of this statement. He didn't write it with a Spanish accent. I add the accent for color, okay? So he uses first evidence from geology, starting in chapter 7. He has 2 chapters of geology. Geology had come of age at the end of the 18th century and the beginning of the 19th century, and it has been discovered that wherever you have strata like this, that they have been actually deposited at the bottom of the ocean, and therefore the ones above were deposited later than the ones below, and if the fossils are found, as they are found here, this is the Grand Canyon of the Colorado River, about 1 mile from top to bottom, and a little more than 1 billion years of deposits, that we know that those organisms above came after the ones below. And therefore, it becomes possible to reconstruct the succession of species through time as the evolution of the horse. This is a model representation. The first animal that we recognize as a horse lived about 55 million years ago. These are millions of years. There you have him, something that we call Hyracotherium. It's about the size of a medium-sized dog. And from there, the modern horse evolved, and many things changed. Size, the whole habit of eating, the legs, the number of toes. And here you have, this is a way in which we evolutionists typically represent the origin of a species. When a new species arises, we show it as a new branch coming out from the trunk, which is evolving, and so you have new species arising. And when a species becomes extinct, then the branch ends. Most species that have ever existed, more than 99.9%, have become extinct. And we see it here in the history of the horse. You have only one species living now. There have been many in the past. Well, the contemporaries of Darwin said, the critics, if evolution has happened not only from one kind of horse to another kind of horse, but from one kind of organism to another kind of organism, where are the missing links, the intermediate between major groups of organisms? Just the year before Darwin published The Origin of a Species, this creature was discovered, Archaeopteryx, which has the skeleton, by and large, is that of a dinosaur. It was a small animal, about the size of a blackbird or so, a vulture, and I mean, sorry, not a vulture, a crow. But then the beak is very much like a mother bird, and it has feathers. So here you have an intermediate between a dinosaur and a bird. Birds evolved from dinosaurs. And actually, Darwin incorporated this fossil, the description of this fossil, in later editions of The Origin of a Species. Here you have an intermediate between fish and amphibians. Up to about 10 years ago, we knew lots about this kind of animal, which is a fish, but has some features, including the brain that we cannot see here in the head, that are already similar to amphibians. And this also was known, that was very much clearly already an amphibian with limbs and the proper shape of the cranium. Now, this one up here, Acanthostega, that lived in 370 million years ago. This other one, Panderictis, lived 380 million years ago. So a group of scientists from the University of Chicago went to the Inuit territory in northern Canada, starting about 8 years ago or so, because they knew there were deposits about 375 million years old, intermediate between the dates of these two others, looking for the true intermediate between fish and amphibians. After 3 seasons, 3 years of work, eventually they discovered this animal, Tiktaalik, which is very much an intermediate between amphibians and fish. Of course, the missing links that were mostly in the minds of the people, in general, of the critics, were those between non-humans and humans. If we descend from ancestors that were non-humans, where are the intermediates? And at the time that Darwin died, no fossils were known of ancestors that would be of humans after the human lineage branched off from the lineage of the chimpanzees and other apes. But now we have lots of them, indeed. So covering this part of this branch, going from the common ancestor of chimps and humans to humans, and now we have literally thousands of them. For many reasons, including investment by foundations and by the US and other governments, now the number of fossils and different species that have been discovered is enormous, going from these early species, which were bipedal but had a small brain, to now Homo sapiens. In addition to paleontological evidence, Darwin used biogeographic evidence, which I will say a little bit about in a moment, but also what we call comparative anatomy. For example, why the leg of a dog, the wing of a bird, the arm of a human, and the flip of a whale, why would be the sign made up of the same components organized in precisely the same way? The whale uses it for swimming, the bat or the bird for flying, the dog for running, and we use it for handling objects. Well, the only reasonable explanation is that they have inherited this configuration from a common ancestor. In fact, the tiktaalik that I was showing you a moment ago, although it was not known, of course, by Darwin, and then they have been modified for serving specific different functions. But otherwise, it does not make sense. You know, engineers don't design boats and airplanes and cars made of the same materials organized in the same way. Obviously, for different functions, things are designed in different ways. That's not what happens with organisms. Now comes the 20th century and 1952, and the structure of DNA is discovered. It was known that it's the hereditary material, and as you know, it was discovered it has this double helical structure, and that has given rise to a new branch of biology, the most active and the most productive, and involving the most people nowadays, molecular biology, applied to various fields, evolution and many others. So shortly after the discovery of the DNA and the understanding that the DNA carries the genetic information, the hereditary information that is passed from parents to progeny, that determines whether the eyes are going to be blue or brown, or the configuration of the arm or whatever, is in the sequence of these letters of the DNA alphabet, which are only 4 letters. But there are, in the case of humans, we inherit 3 billion letters from our father, 3 billion letters from our mother. If we were to print 3 billion letters in a book, it will require about 500 books the size of the Bible. We now have many genomes, including the human beings sequence, but of course we don't print the genomes, we deal with them electronically. But this to give you an idea of the tremendous amount of information which is in the DNA, and also in the proteins and enzymes, which are coded by DNA, and they are the ones, the enzymes are the one that carries the process of life. So in applying the molecular biology to evolution, the first major case was this of cytochrome C, where 2 scientists, the leading scientist there was somebody called Walter Fitch. This is in 1967, a paper published in the journal Science. Walter Fitch was a professor in the Department of Ecology and Evolution at my university, University of California, in Irvine, until about 8 months ago when he died. What he pointed out first and more clearly than anybody else until then, how we could use molecular biology to prove evolution. At the time, we didn't know how to sequence DNA, how to read the letters of DNA. Now we do that. Now it's much easier to read DNA than to read the protein, the sequence of letters in the protein components, the enzymes that are coded by the DNA. But he had to do it with proteins. So he took this enzyme because it's very small. It's a small gene, small enzyme, consists of 104 letters, which are here represented in sequence. The top line is for humans. The second line is for rhesus monkeys, going all the way to down here. And the third line is for the horse. And here I have shown in color the differences. So you compare the humans and monkeys, out of 104 letters, there is only one which is different. Isoleucine in humans, threonine in monkeys. If we compare either one of those with horse, find either 11 or 12 differences. So if evolution is a gradual process, and here we have, let us look only at the upper part, and we have this very simple matrix, human to rhesus monkey, 1 difference, human to horse 12, monkey to horse 11, then we know that evolution has to have been this way. A common ancestor, very recent, relatively speaking, of humans and monkey, and a much more remote ancestor of horse and the humans and monkeys. And moreover, the change in the difference between humans and monkeys happen in humans, not in monkeys, because monkeys, they carry the same letter as horse and other animals. So it means it changed in the human lineage. So that's the way we do now molecular evolution to reconstruct evolutionary history. They look at 20 species, and they created this matrix. They fed it to a computer. There is no way to analyze by hand this matrix and trying to reconstruct the optimal evolutionary tree, but the computer gave them this tree, not this particular drawing, which is actually mined from the Encyclopedia Britannica, the very long article on evolution that I have been the author of for 25 years or so. But anyway, there's the representation, the same representation that they got. Here you have an ancestor which has one branch going to yeasts, another branch going to animals, then that branch splits, you have a branch going to the insects, another one going to vertebrates, and so on. So here you have 2 billion years of evolution from that ancestor of yeast and humans to modern animals and modern yeast and modern insects included. That ancestor lived about 2 billion years ago, and just looking at a little protein or a little gene, we can reconstruct that. And we have thousands and thousands of genes and of proteins. So there's no limit now as to the precision with which we can reconstruct the evolutionary history of living organisms. There are no missing links, there are not missing anything with respect to living organisms. The organisms that became extinct in the past is different. We may not know the details, but for all living species, the 10 million or so species that live in the world, we can now reconstruct evolutionary history with as much detail as we want. It's a question of investing money and resources. And we do this of course, all the time with particular groups of organisms. And here you have a summary of what we know of the whole tree of life, again reconstructed by molecular biology. We have bacteria. You all have heard about bacteria. Many of you have heard about archaea. They are bacteria-like microorganisms which were only discovered about 45 years ago. They are as numerous as bacteria, and they, in terms of mass, all the archaea in the world is greater than the mass of all animals and plants, but they're mostly in the ocean. And then you have eukaryotes, which are organisms with complex cells, like we do, which most of them are also microscopic, but then there are larger ones, animals, fungi, and plants. It's interesting to think that 300 years ago, there were only the 3 kinds of organisms that humans knew, and now we know we have all these millions of species. Let me have a simple example of how natural selection works. This is based on a moth in Britain called Biston betularia. It's very common in the wet woods of central England, and it is called commonly the peppered moth. The common name, the scientific name is Biston betularia, but people know it as the peppered moth because, as you can see, if you know how to look, it looks like salt and pepper. You know, the moth is there. Here it is. You see? Now, the one that you see here is a mutant that differs by 1 gene. There's the melanic form. So in the collections of moths and butterflies and birds that British are so fond of having, up to around 1850, all the Viston betularia look like that moth there. Then one collection has one melanic form, and then they start to increase in frequency and more and more and more. And in some of these places in these woods, they become even more common than the typical form. Why? What was going on? Well, what was going on was the Industrial Revolution. Coal used as the source of energy, the producing dust, the dust killing the cover, the typical cover of trees, and making them look sort of dark, black like that. And under those conditions, you see now the peppered moth is very visible. The dark moth is much less visible. The main cause of death of these moths are birds, use them as food, predators, and birds, their eye sees very much the way we see. So in a normal wood covered by lichens, they see the black moth first and they will eat it first. But in a tree covered by soot, you know, what they see first is the peppered moth. So they were eating this, the other ones were increasing in frequency. That's how natural selection works. In this very, very simple example, the things get more complicated. Let me very briefly say a few words about biogeography, because the best place to study evolution, ongoing evolution, are islands which are remote from continents, from big masses of land, because these islands have been colonized by very few organisms. Most of evolution takes place in the continents, but on occasion one of these animals, a bird or a turtle or something else, reaches an island, and then the island is unoccupied, it's an archipelago, and then they can evolve there and adapt quickly and cover the islands and spread and diversify. So it's a wonderful place to study evolution, and my first example here is with the Hawaiian Islands. The Hawaiian Islands are the most isolated archipelago in the world, about 2,500 miles from where I live in Southern California. Now, all the Hawaiian Islands are formed right here. There is a hole, so to speak, on the surface of the Earth through which volcanic eruptions happen. They happen intermittently. Sometimes they go for many years. The Kilauea volcano, which is the one which is active now, I visited when it was not active in the early 60s. Now, since the middle 60s or early 70s, has been active continuously. So the big island of Hawaii is growing, is adding material there. Well, another thing that is happening here is that these islands are standing on what is called a tectonic plate. One of these plates that made the surface of the Earth, and this Northwest Pacific tectonic plate moves at a rate of about 2 inches per year in the northwest direction. So the islands which are formed here, 4 million years later is Kauai, they are there. And of course, 20 years later are Midway Island, for those of you who are of my age may remember from Second World War. That was also formed right here. So when there is continued eruption, an island is formed. When there are no eruptions for a period of time, then a new eruption starts to accumulate from the bottom and eventually crosses the surface of the ocean, but becomes a new island, and it's how we have these islands being formed. So if we look at the fauna of Hawaiian Islands, the native fauna before humans introduced other species, is very peculiar because it has very few kinds of organisms, and those few kinds are very diversified. Let me start with Drosophila flies. These are the flies that we geneticists use in the laboratory to do experiments because they are easy to handle and have other advantages. There are 2,000 in the world. Hawaii, with the total area, will be certainly less than the state of New York, has 25% of all the species of Drosophila. Why? Because it happened that the Drosophila fly got there relatively early, one female, which, or several individuals, somehow carried by wind or in flotsam, and there were no competitors. So they started to diversify and occupy different islands and differentiate into different species. Insects, 3,750 species. More than 99%, that is actually all but one, exist only in Hawaii. The Drosophila of Hawaii exists nowhere else. This endemic means that they exist there and nowhere else, as naturally. So here you have insects. Well, 3,750 insects, species, may not seem to you very few, but actually they're very few. We have 700,000 described. So this is a very tiny fraction. And moreover, are of a very few kinds. You see, 15% of all those insects are actually Drosophila species. Then you look at the snails, and you have quite a good number of species there. You have birds, moderate number of species, but all but one, again, native to Hawaii and nowhere else. Now notice, or you may not have noticed, that there are no reptiles, no mammals, and not many other kinds of organisms. They never made it there. And as natives, they never evolved there. However, if you consider now not Hawaii, but the Galapagos, Darwin didn't visit the Hawaii Islands. He was very interested in islands. A curiosity, interesting for me, being from Spain, is that the first stop that he made after he left Plymouth was the Canary Islands in the east coast of Africa, which are part of Spain, are provinces of Spain. But the governor wouldn't let them come out because he wanted to put the boat in quarantine for 40 days. And clearly Darwin and the other people in the boat, the commander, were not ready to wait 40 days to explore the Canary Islands, so they continue towards Latin America, today Latin America. Anyway, after having spent a lot of time in southern South America, and Darwin himself was getting out of the boat, was in this boat, the HMS Beagle, that left in December of 1831, and went 5 years around the world. Darwin would return in 1836. And much of the time was spent in South America. There was a ship of the British Navy and had been commissioned to draw more precise maps of the coast of South America and do other things. But Darwin was free to go to the land and explore in land the animals and plants, and he of course was fascinated by the fact that the flora and fauna, the plants and the animals, were completely different from those from the old world. And of course that got immediately, soon, his interest in evolution, that is how it arose. It was not there before. And then in the way back, the HMS Beagle went to the Galapagos and then eventually through the various other places in Australasia and Pacific Islands, and came back to England in October 36. Well, here you have the Galapagos Islands. They were named Galapagos by the Spanish sailors who discovered them because they have these tortoises. The word for tortoise in Spanish is Galapagos. And what Darwin discovered is that each island had a different species. And the Spanish sailors could tell him from what species a particular animal, from what island, a particular animal came from, because they were familiar with them. And Darwin was fascinated by the fact that they move so slowly, less than 1 mile per hour, and they are very sluggish animals, huge, about 200 pounds, the adults. And how could they survive, animals like that, with no defenses? Well, because there were no predators. There were no mammals, there were no animals there that could eat in the Galapagos Island, they could eat these turtles. He also discovered the famous Darwin's finches, this number of species which all derive and are related to only one species that exists in the western South America part, from which is about the same latitude as the Galapagos Islands. Galapagos Islands are about 600 miles away from the country of Ecuador. They are actually on the equator, which gives the name of that country. And he found that these birds have evolved different habits of eating, fed on different kinds of food, different beaks, all of them evolved obviously from one single ancestor in the mainland. Let me now, to finish, talk a little bit about intelligent design. Intelligent design, as you know, is a new notion with that term that was put at the beginning of the 90s, the 1990, so less than, about 20 years ago or so. And the idea was to develop a theory that will negate evolution and will assert that organisms are all being designed by God. But for the theory to be taught in the schools, it could not claim the organisms are designed by God. So they are designed by an intelligent designer. And when in a trial in front of the court of law in Pennsylvania, the proponents of intelligent design asking, who is the designer? Oh, we don't know. Could be a person from another planet, or could be some very intelligent engineer that lives somewhere in the world. I mean, totally absurd explanations of the sort. But the argument is the same argument of William Paley, not anywhere as well developed as William Paley, but the argument that when you have something made of many parts that all are needed at the same time for the part to function, they could not have come by accident. They have to have come by design. Now, the one thing that the intelligent design, particularly this author, Michael Behe, who is the only one who is a bona fide biologist among the proponents of intelligent design. The one difference between him and William Paley is that, of course, Michael Behe knows about natural selection. But he says natural selection proceeds by little steps, like in the case of the color of the moths that I was showing you. But the eye cannot come about by little steps, because unless you have the cornea and the lens and the retina and the optic nerve and everything else at the same time, the eye doesn't work. So that is his argument. And here you have a statement about how do we confidently detect the sign when a number of separate interacting components are ordered in such a way as to accomplish a function beyond the individual components. And he formulates a principle that he calls irreducible complexity. When you cannot reduce these components to one at a time, they have to be all together. Well, what I want to tell you about intelligent design is first that the criticism that they make of evolution is wrong. That is, the notion that natural selection cannot accomplish complex organs like the eye is wrong. Second, that it is not science, intelligent design, in spite of what they have at times claimed. And what I hope will be most interesting is that it's contrary to religion. Although they are proposing it to try to help, in quotation marks, religion and faith in God, it works backwards once one understands what the implications are. So first of all, the critique of evolution is wrong. Take the human eye, or an eye which is as a complex organ. Can it come by evolution? And the answer is yes. We can demonstrate this nowadays very clearly with molecular biology and find all the steps. But we can do it also with living organisms. Mollusks. Mollusks is a group of organisms much larger than the vertebrates, that's our group. And moreover, they live in many different environments, and moreover, they live in environments like the ocean that have not changed over millions of years. So we can have primitive eyes right there, like this of a limpet. If you would live where I live and you will walk to the beach, to the intertidal, there are these little mollusks which are cylindrical, the size of the largest size of a fingernail or less, and which you look at them when they low tide and they are grazing around eating the little microscopic algae, and so that the tide has brought in. Well, these animals, all what they need to know is whether there is light or there is no light. If there is no light, means there's high tide. They are underwater. They attach to the rock. Because if the tide takes them to the open ocean, they die. They cannot live there. They attach themselves with such a strength that sometimes when I take my students or children and say, we see one of them, say, you are quiet, and you see them moving, I say, why don't you pick it up? You try to pick it up, no way. They attach themselves to the rock, even with a pocket knife, as it's almost impossible to detach them, but that's what they need to do when the tide comes, so that they are not taken away. When there is low tide, there's the time to eat, they're still moving around. Here you have another mollusk. This is called Pleurotomania, technically. It's called the slit shell. It's a mollusk very well known in northwestern Spain and in some parts of China because it's a delicacy. Does not exist here. Sometimes I have found them in some restaurants. They imported from China, from Spain. But here you have a mollusk with a little more complex eye. The previous one, all what it had is some pigmented cells, which allow to perceive whether there is light or not, and a few fibers to record the information. Here you have a few more cells, and of course there is this convex configuration that allows them to see also to detect motion. Then you have this marine snail, Nautilus, which is one that was mentioned by Darwin in The Origin of a Species as a fossil, an animal that had not changed for millions of years, because they had fossils for millions of years earlier, and they're identical, at least in external configuration, to the modern ones. So this can detect movement and the direction of light, and in addition to whether there is light or not, here you have another marine snail, a little more complex eye, and here you have the eye of the octopus, which is as complex as ours. Here is the retina, and here are all the other parts. And here are the nerve fibers, which form the optic nerve here. The octopuses and squids have an eye which is as accurate for vision as ours, or better, and it does not have an defect that we do. We have the defect that the optic nerve is formed inside the eye. This is for historical reasons of how the eye evolved in vertebrates. So now the nerve, to carry the information from the retina to the brain, has to cross the retina, so we have a blind spot. The octopuses and squids have the optical nerve formed outside the eye, so they don't have this defect, which should lead the proponents of intelligent design to conclude that God loves octopuses and squids more than God loves humans, which is not a nice thing to say. Well, it's not science. When they started to propose these ideas, they were saying that there will be great discoveries using this theory, but nothing has been done in science. Nothing has been published in honest, bona fide scientific journals. There are a number of books and also leaflets and the like. There was this trial in the central Pennsylvania district of Dover in December, actually went for 6 weeks. The decision of the judge on December 20 by John Jones, a judge appointed to the federal court by President W. Bush, not suspicious of being anti-religious or liberal or the like, and is also describes himself as a born-again Christian, and yet as presiding over 6 weeks, for 6 weeks over the trial, he says, among many other things, the decision has 139 pages. The ID movement misrepresents the status of the theory of evolution. So the critique of the theory of evolution is wrong, and presents students with a religious alternative masquerading as a scientific theory. There's no science there. The theory as formulated cannot be tested. There is no any evidence. Philip Johnson, which is a retired law professor who has written 2 or 3 books about intelligent design, retired law professor from Berkeley, said in 1998, give us 5 or 10 years and you will see scientific breakthroughs biologists had not dreamed of before I did. 5 years went by, 10 years went by, nothing. And now my final point, and the one that I hope to persuade you that is valid, that is intelligent design is contrary to religion, because implies the God is incompetent, the God is cruel, and it amounts to blasphemy. Look at consider the human jaw, for example. It's not big enough for our teeth, so we have to have, many of us, the wisdom tooth extracted because they don't fit, they come out. So an engineer, as I like to say, an engineer in our engineering school who would have designed the human jaw will be fired the next day for being incompetent. You design a jaw is not big enough for the teeth. And there are many other problems. Of course, the birth canal of humans is not big enough for the head. We know the explanation for this. Starting about 2 million years ago, among that list of ancestors that I showed you very quickly, and the ancestors of modern humans, about 2 million years ago, the brain started to increase in size because it was very adaptive, was favored by natural selection. As the brain increased in size, the head increased, there was selective pressure for the head to become smaller. So the jaw started to become smaller and smaller, and the birth canal of women of mothers started to become a little larger, but the selective pressure was primarily on the size of the brain. That's what was favored by natural selection. The other pressures were secondary. That's why they are not as accomplished. The jaw became smaller, the teeth became smaller, but they're still not well adjusted. The birth canal became smaller, but still not small, not large. I mean, became larger. Sorry, but not large enough for the birth to take place naturally. That has caused the death of millions and millions and millions of innocent children and millions of mothers. Now we can give that a religious interpretation, which is perfectly valid. But from the point of view of biology, it just does not make sense that it would have been designed that way. By the way, chimps or gorillas don't have a problem when giving birth. It's actually lots of fancy chimps giving birth to babies because it becomes a collective joy, and the female is going to give birth, is moving like that, and the other ones are around, they're all happy, and suddenly goes, whoop, and there it is. And they just break the umbilical cord, and everybody's happy, you see. Not the same as it happens with humans. There is a lot of cruelty in the living world. I mean, chimps, we think of chimps as nice animals. It's nothing nice. They eat most of the time leaves and the like, but whenever they can get of a small monkey, that's their favorite food. And they like to eat them live, so a bite at a time. And the poor monkey is, crying to high hell, and the chimp is having so much fun as the poor monkey is shouting and suffering. And there are many, many examples that one can go without end of cruelty. And then interesting situations like the well-known praying mantis that, if you care, any of you care, can ask me afterwards, and I will say a few words about it. And then there are parasites that exist. The only reason why parasites exist, and the only way which can exist, is by making their host sick or killing them. I mean, this is sadistic. If somebody would have designed organisms, that's the only way they can live, by killing other organisms, which presumably were also designed by the same designer. So it's why I say that evolution is Darwin's gift to religion. And in fact, I wrote a book that Father Cohen didn't mention, has the title Darwin's Gift to Science and Religion. Thank you very much. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you.
Well, the applause makes it clear that we've stirred up a bit of, what shall I say, discussion here, which we welcome. I think even Francesco has been a bit provocative, maybe the word, so let's hope he's provoked a few of you to join in.
You said a bit provocative, a bit, or a lot?
We'll talk about it over a glass of wine. Before, however, we begin, if you're going to provoke any discussion, I've been told very clearly that if you approach the mic to ask that everyone not just mute their cell phones, but shut off your cell phones, because there's interference between these mics and your cell phones.
And also, I believe the recording, is it? It's being recorded. It's being recorded, isn't it?
This is being recorded, yeah. But let me make the point that the circuit is such that your cell phones will interfere if they're turned on, not just muted, okay? So, I welcome discussion, provocations, whatever.
Okay.
If not, please.
Always a pleasure to be with you, Ralph Singh. It seems to me, and I may be wrong, but you have spoken as much about unnatural selection as you have about natural selection. You start with the image of war, and you start with an image which suggests selective vision and selective choice on the part of people in interpreting the theory of evolution. And perhaps you're suggesting that, and I'd like to hear from you, that as opposed to having science try to prove God's existence, perhaps you're suggesting that in the process of looking at natural selection, we could be more natural or godly in our understanding of how to be more in harmony with nature. Is that a possibility?
Well, I am not completely sure that I understand the gist of your question, but I will say the following things. First of all, natural selection is only one of the components of the theory of evolution, and evolution involves also chance events and many other kinds of processes and laws and the like. Second, that is natural selection, and as a theory, allows us to explain the sign. So in a way, all what I was saying is you can explain the design of the eye without having to have like the explanation for the watch, a watchmaker that makes the watch. I don't need have a designer to design the eye. It can come about by natural processes. That does not mean that God does not exist in any way. It implies, as you correctly say, at least according to my view, that the science is the wrong way to try, the wrong thing to use to prove the existence of God. But because science can neither prove nor disprove, but certainly because of that, it does not mean by any means that God does not exist. That we can describe your birth, starting from a little cell in your mother's womb, and dividing the cell into many cells, and then a baby was born, and here you are 50 years later or whatever. We can describe that as natural processes that not exclude a religious view of human life. These are different dimensions of reality. They are compatible, but we should not confuse them, which is what the proponents of intelligent design do, and I think to no avail first, and second to the, unfortunately for religion, because they present a view of God, imply, they don't hold that explicitly, but they imply attributes about the Creator that we are not willing to accept.
might just add to that question. That's why I think the title, though it's very simple, is it's science and religion in modern America, modern society. No sides are taken between science and religion. And I think Francesco has made a very strong point. There is no way within science to take sides. If you bring in God or discard God, you're not doing science. You're doing something else, right? Please, Gerard.
Thank you for a wonderful talk. I don't think I'm on.
Just. That's all right. God is listening, so don't.
Now we
Well,
know that
I
college presidents are useful, right?
I was just wondering, Father Coyne had brought up an interesting question for our class, having to do, and I think you addressed it in some way, but if you have science and you have religion, where do they contact? Where do they meet? Does science confirm religion? Does religion confirm science? Is there, I know you're going to say no,
Yeah,
because
no.
science can never confirm
No.
religion.
I-
Science can't confirm God. Where's the dialogue? When do you talk? You look out two windows. I look out the window of religion. I look out the window of science. When do I bring those two windows together?
But you are giving the answer. Where they meet is in you, not science meeting religion in science or science in religion. It met in each one of us. As we look at the world, we can consider the religious dimension and the scientific dimension. Let me go back to my favorite painting, one of the most famous paintings in the world, Guernica, which is now in Madrid for many years, was in the Museum of Modern Art in New York. You can take that painting and describe the size, the material it consists of, the canvas. You can describe the pigments and the colors. You can even give the coordinates of every brush stroke that Picasso used. So that gives a complete description of the painting. All the materials, all the colors, all the design, and all of that. And if I were to tell you, if I was in an art class and give the description of Guernica, everybody will go, huh? You have not told us anything that is interesting about the painting. What's interesting about the painting is the message, the horrors of war, the inhumanity of human to human, or the aesthetic value. These are different dimensions. They are not contradictory, but, they are compatible. So that's the way I see science and religion. They meet in us, like the description of the physical attributes of Guernica and its value as a creation of art or as a message of humanity. Those meet in us and individuals, but they are different ways of looking at things.
Thank you. Thank you, Gerard. I'm happy you mentioned my class. I get a little publicity out of this. No, I would like to reinforce what he said because I think I would like to address a little notion too, Frank. In my class on science and religion, I presented them, which, from the literature, there are 5 different possibilities for the meeting of the two cultures. Conflict, contrast, concordance, support. One helps to confirm the other. And I've asked them in their homework to report to me what I said, whether they like to do that or not, and then where they see themselves from a rational point of view, not from any religious preferences or anything else, as reasoning beings. And that's a challenge. And so I would like to increase the little challenge. Pardon me a minute, Pat. You say in each one of us, we have to approach this, how do they meet? But the challenge of this series is, where do they meet in to limit it to American society? And as you know so well from this pamphlet that you chaired that committee, it's a challenge in American society to have a meeting ground between the science of culture the culture of science and the culture of religion.
And
We're
yet
all over the lot.
they are two of the three great pillars of our society, and yet many people see them as in contradiction.
That's right. And where do we meet? Patrick, please.
I want to come back to the point that you made about,
What's...
I need the mic, you hear me?
We meet the president. But
I wanted to come back to the point when you were talking about refuting ID, that it gives us a God that's cruel and incompetent and so forth. But I want to come back to that. When you mentioned Guernica again, it occurs to me that amazing painting. We can see some of what's going on in there. We see sort of reference to Titian's Rape of Europa, and we can feel Picasso's rage, his outrage about what happened. But there are many details of that painting that clearly come from the dream world and the unconscious, and a lot of the symbolism has never been explained. The painting is chaotic, and yet when we look at it, I mean, it's a visceral response. And the thing that's amazing to me about that painting is here it is. Its origin is Picasso, not a particularly political painter, his outrage at this blasphemy that was committed. And now that painting is an icon for world peace. When we see it now, we look past the violence and see it as representing the longing for peace. Now, if I'm not too incoherent, to weave back to what you're saying, it seems to me you're absolutely right. Of course, intelligent design is not science. But evolution, which we must accept, I mean, the evidence, as you've pointed out and many others, is absolutely overwhelming. But isn't it also true that if we follow evolution, we also seem to end up, I can see I'm going to have to discuss this later with Father Coyne at least, we also end up with a God who may seem fairly cruel. As you pointed out, 99.9% of all species that have ever existed are extinct. I mean, it is a sort of slaughter bench as we go through history to see what manages to survive. I know there's an answer to this, and that's where I'm getting at the sort of the Guernica thing. There is a kind of peaceful resolution. I can see a God presiding over everything somehow that makes it all work out, but on the face of it at least, it does seem like a pretty brutal process, evolution, which I assume everyone in the room accepts, and we see the results. And even you mentioned parasitical things, river blindness and so forth. Someone looking at that might say, how can there be a loving, omnipotent, all-knowing, all-loving God who would permit river blindness and guinea worms and all these horrors, etc.?
Yeah. Let me answer starting in a paradoxical way. Animals are not cruel. Nature is not cruel, because animals are not moral subjects. There is no cruelty there. We can be cruel. A designer who designs cruelty will be cruel, but the animals no. These are natural processes. Volcanic eruptions and earthquakes and tsunamis. So these are natural processes. You don't predicate moral values, like cruelty or any related one, from subjects, from entities that are not moral subjects. Let me see whether the following helps. You see, I live in top of a hill. Just crossing the street is an ecological reserve. And my wife and I very often cross, and almost daily, and take long walks there. It's beautiful, and Southern California has almost as nice weather as here these days. And we see coyotes. And coyotes, they are individual, even when they are large males. If we come close, they run away. Except when they pair with their babies, then they will hold their ground. And you better don't get close, because then they are going to attack. Well, as a piece of information, but assume that I'm attacked and I'm beaten by a coyote. I would not say that coyote is immoral, is doing something wrong. However, I have a neighbor who has a very nasty dog, and takes the dog to the ecological reserve and throws the dog at me, and the dog bites me. There's a moral action. The difference is that there's the subject that is moving the dog to bite me. That's where the morality is, not in the biting. The biting by an animal which is not a moral subject, or the killing babies or whatever, or the other events. There's no morality there. Simply, they are not moral subjects. So that's my view of it. I don't know whether you find that answer satisfactory, but so I don't think there is really a problem there that needs to be solved. It needs to be understood. And that can be applied the same to Guernica, but perhaps enough said, because I see a number of people.
Please, next, if you would.
The main thing I've found in your text and the other text I have of yours and a couple other things I have that you've written is constantly saying, religion plays an important role in people's lives and so on, and this is the science and religion in American life, and I was wondering, what do you define religion as?
Okay. Well, I'm not here as a theologian, and I think almost anybody here could define religion as well or better than I do, and certainly Father Coyne. So I am going to pass. I could give it a try, but I think I know what religion is, and religion has many components. One of them is the worshiping of God, and of course there's major component. The other one is moral values and the relationships among human beings. But I'll leave it at that, unless...
There are a few students in my class here. I'm going to tell them what religion is. Okay, I knew I wasn't going to get away with that one.
Get a little closer to the microphone, not too close. But, oh, you have definitions of religion. Well, not too close. You don't have to hold it. Okay, that's right.
I've been reading a lot into what's religion, what is religion meets science, and all that, and it's constantly I'll find in your text, page 7 specifically in Faith and Science, you have a dialogue with you and this one guy, and you say you keep talking religion of the importance of religion and such, and how you define it, what you mean by it is to see where you're coming from in the debate and in the correspondence, what you think you're talking about, if that makes sense. That's kind of my issue.
Francesco, if I may, it's true. What you're saying is religion is a floating. Let me give it a try. Religion is the practice of the faith. So it's going to church, being a good person, saying your rosary. Faith is a gift of God, pure gift. Not reasoned to, not earned, it's given. It's not a miracle, and it's given to each one. We each walk our own walk. So this would take, I'm preaching to my class now, so that's why I tried to ask. You have to grab on to faith, first of all, and you can't rationalize it because it's not faith. You can't reason to it. You can't beg for it. Augustine is my hero in this. I searched you, God, in the confessions, down the highways, down the byways. Searched you night and day, and I only found you when you found me. Now that's not, that's preaching. But to me, unless you have that conviction, then talking about religion makes no sense. It's a practice of that conviction. Now, I have practiced religion without having faith. My mother beat me to go to church. Religion is a kind of a floating, squirmish kind of thing, because there are undoubtedly cases where a person is religious but is not doesn't have faith. I practice religion because I really like that girl. And, you know, and she is religious, so we could get way off, but I think you're absolutely right.
We'll save it for
As
tomorrow.
we are now. Andy, I think you were in line next,
you are.
please. Sorry about that, folks.
Well, most of my life I had been studying and teaching evolution, and my experience is, of course, very much what you say, that it becomes very meaningful if I look at it from the point of view of my faith. So really science did not give me faith, but faith makes my science meaningful. But what my problem with the intelligent design is that here again we might be committing the error of what is called anthropomorphism. That means we explain something that is not human in terms of human experience, and that is not justifiable in study of animal behavior or in theology. So my problem is then that in this sense that this anthropomorphism, that we actually try to create a God in our own image and instead of the other way around, and it is not justifiable to me. So the unfolding of life as I know it is creation, and that makes beautiful sense. But my faith doesn't come from my science. It is a gift, as you said. And to ask for it is already, it's so readily given that to ask for it is already an act of faith. So, thank you.
Well said. You brought to my mind an anecdote, which I think is correct, is valid, is true, that it is the person who first proposed what is now known as the Big Bang, because Big Bang was the name given by Hoyle to make fun of. Anyway, he was a Belgian priest, and he was made a member of the Pontifical Academy of Sciences. He may have been president. And I think the anecdote goes that the current Pope, and it may have been Pius X or so by the time, told that, Father, what was his name? The discoverer of the Big Bang.
Georges Lemaitre?
Lemaitre. Father Lemaitre, now you have proof creation by God, because now we know the world started in a moment in time, and according to the anecdote, the response was, Your Holiness, please let us leave science for the scientists and religion for the faith, but let us not try to use science to prove religion. So he was not willing to accept that you could use, even in that case that seems so obvious, account of creation. He was not obvious. He was not willing to use science for that purpose.
Right. Yeah, I'll add a word to that, and then we'll have. Georges Lemaitre was a Belgian priest. He was accused of being a Jesuit, but he wasn't. And he was the first who wrote what he called the primeval atom, which was the first intuition of a Big Bang cosmology. But there was no evidence whatsoever, none of the modern observations. But he wrote the book. It was a great intuition from the fundamental equations of Einstein, etc. And Pius XII was addressing the International Astronomical Union. And he heard about this, and Lemaitre was president of the Pontifical Academy, so the Pope felt he could use what Lemaitre has written. So the Pope said that you scientists, essentially he said, you scientists are finally discovering what we've known from Scripture and theology ever since, namely fiat lux. God made light, and you're discovering it through science. Well, Lemaitre went into a fit. And he had an audience with the Pope and said, Your Holiness, you're infallible, but you're wrong. This has nothing to do with the book of Genesis and God creating the universe. Nothing, zero. First of all, it's not yet science. It's kind of an intuition. But even if and when it becomes science, it has nothing to do with. And
Well, Father Lemaitre, Georges Lemaitre, was a very, very great scientist and a great priest. And the fact that he was not a Jesuit proves a point that I like to make. Nobody's perfect.
Oh, man. Did you hear that? Please. Thank you, Francesco.
Two-part question, I guess. The first is that, so we see science and religion don't necessarily have to be contradictory in any fashion, but
Do you want to use this, Francesco?
Oh, I use that, yes.
Step up here. Can you hear me? You don't want to hear me.
As to, I think the questions are very good, but as to how we can consider ourselves creations of God, if we are the results of evolution, I would say the same way in which you, at least I, consider myself a creature of God, a creation of God, that for affirming that, I don't have to deny that I came from an egg in my mother's womb and there's all these biological processes. And the other part of the question about the history of the burials of the Neanderthal, again, I'm not sure that I got the gist of your question. It seems that Neanderthals have practiced burial. There are enough findings, independent, that seems other related species to us don't seem to have. For me, the important thing of that is enter into a new subject, if you wish, is that proves that Neanderthals, like we do, they knew they exist as individuals. I am of the opinion that no other animal than humans knows that he or she exists as an individual. You know, my wife does not agree with me. She thinks our dog has a very good personality, but I don't think so, and not even a chimp or so. And the proof valid to me, I'm not trying to persuade everybody that this proof will be convincing to everybody, is that if you know that you are an individual, then you know you are going to die, because you see other members of the species dying. And when one knows he or she is going to die, then he's going to treat the other dead individuals of the species with respect. That is, will be ceremonial burial of the dead. And only humans among living species practice ceremonial burial of the dead. To me, there's evidence that other species, the individuals, do not know that they exist as individuals. They have lots of processes, you know, through the senses and other ways, but I don't think they exist as individuals. Now, it seems that Neanderthals did, if one uses this logic.
Thank you, Francesco. Now I forget which of you young ladies stepped up first, but we'll go this way. To my right hand, please.
It's on? Oh.
Yeah, good.
Okay. I'll start off by attempting to answer the question as to what religion is. There was a philosopher called Ludwig Wittgenstein, and he's a philosopher of language, and he proposed that when you try to nail down what a word means, that's when you run into philosophical problems. You say, what does religion actually mean? What does it really mean? That's when you get all these philosophical debates that are just nonsense, because the truth of language is that things can only be understood within the context of the discussion. He called these language games, sort of. So, for example, like, you can't really define religion. You can only throw us a bunch of kind of Christianity-related things that how you understood religion, where if you ask the same question to a Buddhist, they would not have listed, like a faith in God, a gift from God. They list some kind of moral theory, utilitarianism, something like that. So that's how I'd start that. He basically said that religion can only be characterized by a list of family resemblances between them, and you don't have to have certain things. You just have to have kind of a vague relation to one another, I guess. So I'll start that. Okay, and my question is, I can't get to the question yet. You're saying that you're not divorcing, but that science and religion are two different things, or two different windows. And I want to challenge this, because I think it's impossible for someone to look at science and the kind of picture of the world that science is offering up, and to kind of divorce the meaning they have in life from that information. That's what religion kind of is about in all its different forms. It's just about a sort of meaning in life, what's our position in life, and lots of different various aspects of life and meaning, I guess. To say that you can divorce yourself, your meaning, from those numbers and figures and theories of the world is, I don't think you can do that. For example, like on my finger right now, you could say this is my religion. I have the Mobius strip as a ring that I wear every single day, because my moral theory and my position in life and what I do with myself is largely based around this Mobius strip, the idea that the universe is expanding and that we're just a really tiny, small piece in a really, really big place. It positions my place in the universe, much to the likeness of religion. So to say that you can divorce science, something objective, from religion, something subjective, something that creates meaning, it's really to say that you can divorce that.
I think you have made the point.
Okay.
But my response is that I am not, and I don't think Father Coyne or many others are suggesting that we divorce religion from science. We are saying that there are different windows to look at the world, that what you see is different, it's the same world. But let me go back to two analogies that I have used today. One could be the development of the individual, and the other could be the Guernica. You can give the physical description of the Guernica. Nobody's going to say they should be completely divorced from the description of the Guernica as a work of art, or the description of the Guernica as a historical document. No, it's not divorcing it. On the contrary, they are things that go together and they supplement themselves very well at the level of the individual. But trying to confusing them is what I think is not productive. But certainly, again, that kind of issue was raised earlier. It's in the individual, in the person, where the two things come together. Yeah, you want?
No, thank you for that intervention. We appreciate it. Katie?
Okay. Dr. Ayala, I want to sort of bring your attention to something that was discussed in my religion class today about one of the first baptismal promises that we make is that we believe in God as creator. And now I know for me, because I study both science and religion. And anybody who knows me will tell you that while being a very devout Catholic, I'm also a very devout evolutionist. I know for me to say that God is creator, even though I'm a devout evolutionist, I can understand how God can be creator while not being creator, while the earth, what happens on earth happens through natural processes. But for someone who isn't educated the way I am, by having the opportunity to be at a Jesuit university and to study biology with some of the greatest professors and also study religion at the same time with some of the greatest professors in the world. I'm not trying to get A's, by the way. But how would you explain it to somebody who isn't so well educated, to sort of explain how it's possible for God to be creator while also following evolutionary principles, while following science, and sort of not falling into the trap of God did it within science?
I think you are pointing out to the problem very, very well, and it is education. That people who are not highly educated about science or about religion or about neither, then it's very easy to see these conflicts because they make sense, that if organisms came about by evolution, they were not created by God. So the answer is education, and education, and education.
Thank you.
Oh, you are here.
Do we still have, please?
Look at the issue of faith. If we have to prove our faith, we have no faith. And isn't the problem you brought up, Father, in today's society an issue of acceptance? The fact that we do not know why we are here. And we talk about God and religion, and really these are definitional issues with each one of us. We have some kind of a concept we have faith in, but we can't necessarily prove it. What exists is not proof of what might exist. Is that a fair argument?
Oh, it's more than fair. If you can prove faith, it's not faith. It's as clear as that.
So why is this great divide between religion and argument, religion and science?
Because there's a rational basis to faith. You can't prove it, but there's a rational basis.
There's a rational basis, but there's also faith, fundamentally to me, is irrational. It's something we accept. It's a foundation. We can't prove it, and it's a foundation of where we are.
Show me that faith is irrational. Just give me one.
It's irrational by the definition that somehow you can prove it. We have these things that happen to us in life, and we come to accept them. And we have faith in what is going to, that somehow life is ongoing. But we don't know why. We can't prove that. Well, I can't prove that I'll be here in 2 seconds.
It's a question of proving is different from accepting God's gift to me. Does it contradict anything I know by using my head? It's not irrational. The best word to use for me would be irrational. It goes beyond what I can reason to.
Sure.
But it doesn't contradict anything I can reason about. So the word irrational is inappropriate to me for faith, at least to my faith. I don't feel like I have given up thinking by accepting God's gift to me of faith. I just don't. And when I think, the poor thoughts that I have, none of them contradict what I accept from God. None of them. So.
Well, isn't it true that's a two-step process, Father?
Pardon?
That's really a two-step process all the way through. We work our way through, but we have the faith and the hope that things will work out.
Yeah. Good. Okay. Do we have still? Then we're going to have to. It's getting. I know you've upset me more than once. I'll tell you that. Please, Gerard. I'm only kidding. Please. Yeah. Yeah.
Sorry.
And then we'll.
Yeah. Just a thought that if we're talking about.
Sorry.
Where did you come from?
What does religion do? And I think religion does maybe even have sense that religion pulls people together and
Right.
feel good because you have something in common.
Right.
And I think science sometimes can scare people.
Well, science may scare people, but nothing that we have said or nothing that is in science would exclude or negate religion. You said when science threatens religion. Well, science does not threaten religion. Individuals may use it that way, but there is nothing in the nature of science that threatens religion. Now, people, however, precisely because they are not very well educated, they may see scientific knowledge as a threat, may see the expansion of the universe, may see the Earth not being the center of the universe, but being one more planet as threatening religion, but that's ignorance.
Well, it's interesting that you went to Salamanca, correct?
Yeah.
And one of the interesting things to me was that I heard the University of Salamanca is one of the few places that supported Copernicus.
At the time, early on, that's correct.
A lot of people got scared by that because it held them. I'm very happy questioning beliefs. My concern is that religion seems to have become a belief system, and it's really not. But I think in our country, where people are held together by certain common beliefs, where we can't even, it's very sad to think you can't teach science in school. But I'm just wondering if one of the things that can be addressed over time will be, how do you present religion present science educationally when people are scared of it? And I think sometimes that's where the element is not the essence of religion, it's one of the effects of religion.
It's education. Yeah, it's a question of educating people about what science is and what religion is. That's where the answer is. It's no other way. Otherwise, people are going to perceive things as being contrary, whether they are or not. But maybe we should have the last question, because probably people are getting tired. You were starting to ask also.
I'm sorry?
No, he's going to have
This
that.
is the last.
Yes, my question was about the intelligent design when you were talking about like parasites and how we were saying how could omniscient God or a loving God could create maybe parasites, but I was wondering if parasites they exist, like maybe they have a purpose that we don't fully understand.
Yeah, from the evolutionary point of view, they play a very important role. I mean, they're part of the flow of life, and they control size from populations, and they live themselves and do their own thing. They cause the extinction of many species and the death of others, but there's evolution, there's science, and they play a role in the world of life. Parasites too.
Thank you. Well, Francisco, we can't thank you enough. You've obviously stirred up some very interesting discussion, which won't all be solved this evening. So I must announce that there are sequels to this series. And I think the next sequel will be, you can't handle everything in one evening, right? Isn't that obvious? And the sequel, I think, will approach more a scientific study of religion as part of Wesley Wildman's title. Scientific study of religion, the three domains of science, spirituality and health research, and the religion-science dialogue. So we're going to carry on. We know that you have given us a great deal to think about, and fortunately into the series, we hope to think about it a great deal more. So, Francisco, we want to thank you. Thanks to all of you, and the series does continue. The next talk is on November the 5th, and there are little pamphlets out here that announce that. Thank you all.